Hello everyone, my name is Anju and I am from Department of Renewable Energy. In this session, we will explore why we are extensively using the some of the optoelectronic devices. So mainly we are going to discuss two kinds of optoelectronic devices. First one is photodiode and then LED. How they work and what are their applications and what are their advantages. So let us start. So first one is photodiode. We know diode is a p-n junction semiconductor. Similarly, photodiode is a p-n junction semiconductor which converts the light energy into electrical energy. And the photodiode is a p-n junction diode which is also known as a photosensor. Photodiodes are used in everyday life, for example, in the solar cell panels, for the optical communication, for lighting regulations, etc. So I have told a photodiode is a p-n junction diode. So let us see what is a p-n junction semiconductor is. So this is a figure for a p-n junction semiconductor. We have p-type semiconductor here and then we have n-type semiconductor. The majority charge carrier in the p-type semiconductor are holes and the majority charge carrier in the n-type semiconductor are electrons. So as soon as we join this p-type material with the n-type, a junction is formed which is called the p-n junction. So soon the p-n junction is formed. The holes nearby the junction in the p side and the electrons nearby the junction in the n side, they are going to get attracted to each other. So the holes and electrons nearby the junction, they will recombine and a layer is formed there which is called the depletion region. Why we are calling it as a depletion region? Because no free charge carriers are present at the depletion region. The charges have depleted from those region. So we call that as a depletion region. So in the depletion layers, atoms are present. So I have told no charge carriers are present in the depletion region. The charges have depleted away from that region. So the charge of that region is neutral. What is present there? Atoms are present. If you are taking a semiconductor of silicon, silicon atoms will be present at that depletion region. So let us see how the photodiode is working. So photodiode is a p-n junction diode. Here we have the figure and they are designed to work in reverse bias condition. So there will be biasing condition for different devices. In the case of the photodiodes, we have reverse bias condition. So what is reverse bias condition? We are connecting the p type with the negative terminal of the battery and we are connecting the n type with the positive terminal of the battery. We want light to fall in this junction. So this is the depletion region. We want the photons to come to this region. So what we will do, we will make the top layer transparent so that light can come through this region and enter into this depletion region. So this photodiode is reverse biased. That means negative is connected to the p type. So we know here we have the holes and this is negative terminal. Here we have the electrons and this is positive terminal. So this electron is attracted by the positive terminal. So the positive of the battery will draw electrons from the end region. So electrons start to move from here and will reach here. And the negative terminal will sends electrons to the positive or the p-type semiconductor. So how electrons are moving from this region and passing here and will reach here. So what happens now? The electrons here start to decrease. Electrons in the n-type start to decrease or the region here start to increase. And here p-type, in the p-type, the electrons coming from here is going to combine with the hole present here and the hole also vanishes. So that means the depletion layer which was of this width now will change its width and will become wider. So by reverse biasing, the depletion region is increasing its width. Now we will expose our photodiode to the sunlight. So when the sunlight falls here, we know no charge carriers are present there. It is a neutrally charged region. That means atoms are present at the depletion region. So when the light is falling there, uh, the electrons on the outermost shell of the atom, they will absorb the energy from the photon. We know energy of the photon is E equal to h nu. So if we are taking silicon semiconductor, atoms of silicon is present in the depletion region, and they absorb the light from the sun, and they will consume the energy. And if that energy is appreciable amount, that energy is an appreciable amount, the electron will absorb that and will get free from the atom. So now you have a free charge carrier at the depletion region. Why we got a free charge carrier? Because sunlight has fallen into the region, and the electrons in the outermost shell of the atom has collected those energy and has become free. So here in the depletion region, because we have a polarity, positive negative polarity here we can see there is a positive polarity, here negative polarity. There will be electric field acting from positive to negative charge. So because of this electric field, the freed electron from the atom will move to the end region. Right? They are attracted to the positive polarity. So the freed electron from the atom, they will move to the end region because of the electric field. So now this atom don't have a electron. It has a hole, or it has a vacancy which has to be filled. So this atom will draw electrons from the p region. So there are minority charge carriers in the p regions. So this atom is going to collect electrons from the p region. So the free electrons start to increase in the n region, and the holes in the p region will get separated from the electron, and that electron is given to the atom. So the electrons start to move through this and come here and passes the junction, fill the vacancy in the hole. So this process is taking place here. So we can see in the overall situation, we can see the electron is moving from here, and then they are reaching the p type, and then they are closing the junction. So that means electronic charge is there. If electronic charge is there, current is flowing opposite to the electronic charge. So this is acting as a photosensor. Why? As soon as the light is falling at the depletion region, the current is produced in the photodiode. So it acts as a photosensor when light is falling into it. So this is a working of a photodiode. Next optoelectronic device that we are going to discuss is LED. LED means light emitting diode. So this is also one of the form of the diode, but here all the methods are just opposite to the photodiode. So let us see. LEDs are semiconductor diodes that emit light when an electric current flows through it. So in the photodiode, we know light is converted into electrical energy, but here electrical energy is converted into light energy. So that is one of the main difference between LED and photodiode. Used as a standard source of light in electrical equipments, this work at a low voltage and take very little current, and allows current to flow in the forward direction and blocks the current in the reverse direction. That means here we are using the forward bias. In photodiode, we know we use the reverse bias, but in LED we are using the forward bias. So let us see how the LED is working. So this is the diagram for the LED. They are heavily doped p-n junctions. When the diode is forward biased, the minority electrons are sent from p to n. So here we can see they are forward biased. That means p type is connected to the positive terminal and n type is connected to the negative terminal. So just think what happens to the depletion region in this case. I told the photodiode and LED are just opposite. So in the previous case, we reverse biased the p-n junction. So the depletion layer width actually increased. But here we are forward biasing. That means we are connecting the positive to the p type and negative to the n type. We are forward biasing. So what happens to the depletion region width is going to decrease. Why? Because the positive terminal is going to pull the holes from in the p region, because the positive terminal is going to pull the holes in the p region because they are light charges, and the holes is repelled because of the positive charge. And similarly, the negative charge is going to repel the electrons in the n region. And if the voltage is high enough, that this voltage is high than the if the voltage is high than the depletion region voltage, then the electrons from the N region, they will be able to cross the junction and reach the P region if the uh, voltage or potential difference of the depletion region is lesser than the uh, voltage of the battery. If battery have higher voltage, then this negative terminal is able to push the electron and it help the electrons to cross the junction. So once the electron is crossing the junction, that means they are traveling from a conduction band to the valence band. We know the energy of the conduction band is higher than the energy of the valence band. So when this electron is moving from the conduction to the valence band, that means it has to liberate energy. So this energy which the electrons liberated is nothing but light energy. So this is the working of a LED. Thank you.